The psychology of conformity is something you've probably already previously explored, but its study relates back to the 1950s when social psychology pioneer Solomon Asch conducted what's known as the Asch conformity studies. So an elevator experiment to see if conformity plays a part in the elevator was done.
So you walk into an elevator and naturally you turn and face the door, right? It's just what we do without even thinking. Here on Would You Fall for That, we decided we had to pay homage to candid camera.
How this man tries to maintain his individuality.
So right now we are reenacting their famous test of conformity. The elevator experiment. So we found a nice elevator at the Juilliard School and gathered our Would You Fall for That stuff. If we turned to face the back of the elevator, would others follow? All right, in the blue t-shirt, that is Nadia. She is an innocent passerby. Has nothing to do with this. Everybody else in that elevator, they all work for Would You Fall for That. They are all in on the experiment. They are all purposefully facing the wrong way. Nadia is facing the front. You can just see the back of her head, wearing the blue t-shirt, that's Nadia. She is facing the front of the elevator like a normal human being. Everybody else is facing the back.
That's true.
We're playing this to you in real time, no editing, as it actually happened. Okay, floor 2. Rebecca gets off, Emily gets on, she also works for us. We're swapping people in and out to reinforce the behavior. Emily's acting like it's the most normal. Oh, Nadia's turned. Nadia, okay, her bag is slipping off her shoulder. She's nervously playing with it.
Yeah.
Nadia's now halfway round. Will she go any further? Emily gets off, Mike gets on. Again, Mike works for the show. Presses his button, faces the back like it's the most normal thing in the world, like he does it every day. Nadia is really feeling the pressure right now.
I'm not going to see anyone else.
Isn't he on
Scott's making some small talk.
He was on celebrity rehab, I think.
Oh.
Yeah.
She's looking towards the back of the elevator because everybody else is. Floor 4.
I love the guy.
4th floor, Mike gets off. Lauren gets on. Lauren also works for us. She's in. Oh, and Nadia has gone. The 4th floor, Nadia has turned all the way around. She's looking at the back of the elevator. That is not normal human behavior. Nadia is looking at the back of the elevator purely because everybody else is.
Let's say we have some hypothetical data though. Our hypothetical data is looking at group size and conformity in terms of whether people face the back. So let's look at the data collected. There are 200 people in the study and we can see that 70 conformed to the group and 130 did not conform to the group. This is also known as a contingency table. That is, whether you conformed or not is contingent on the group size and vice versa. The research question becomes, is there a relationship between group size and whether you conform to the group or not? Or another way to put it is there a difference in the number of people who conformed and did not conform across the different group sizes? Now that is, does whether you conform or not depend on the size of the group, or are the two completely independent? So I've said that 3 different ways now. Now if they're independent, knowing the group size would not enable you to predict whether they conformed or not, because whether you conformed or not will not depend on group size. In other words, conforming or not conforming will occur in pretty much the same proportions, regardless of group size. So looking at this data, this contingency table, let's step through how we might go about doing this. So the first is to specify the hypotheses and the decision criteria. Now the null hypothesis is that there is no relationship between the number of people in group size and conformity, as measured by joining the group to face the back of the elevator. Or the alternative hypothesis is that there is a relationship between group size and conformity. Now the alpha is equal to 0.05 for a non-directional with 3 or more categories. So the added complication in a two-way chi-square is because it's more complicated to calculate the expected frequencies. Let's look at why and how this is the case, and I'll provide two options for calculating the expected frequencies. So if group size and whether you conform are independent, the proportion of conformers and non-conformers will be pretty much the same regardless of group size. So we have 70 conformers and 130 non-conformers, totaling 200 people in total. So what that means that the proportion of conformers overall was 70 divided by 200, which is 35%. And the proportion of non-conformers is 130 divided by 200, which is 65%. Now the expected frequencies are those that are expected if the null hypothesis is true. Now please pay attention to the logic behind the calculation of the expected frequencies. Let's start with the upper right hand corner. Of all the people in the sample, which are 200, 80 were in group size 2. So if you chose a person at random, the probability that that person would be in group 2 is 80 divided by 200, which is 40%. In a similar way, of the 200 people in the experiment, 70 in the column total conformed to the group. Thus, the probability of that randomly chosen person would conform to the group is 35%, or 70 out of 200. Now, if you ask what the probability is that that person chosen at random is being influenced by a group size of 2 and conforms to this group, the answer is found by multiplying together the probability of the two events. Thus 0.4 times 0.35, which is equal to 0.14. So it's a little bit like if I toss this coin. What's the chances of a heads or a tails? And you're probably thinking to yourself, well, it's probably half-half. Half a chance, 50% to receive heads, 50% for tails. Well, if I flip the coin, I've got half a chance that it's going to be heads. If I flip it again, so if I look and I see it's heads, if I flip it again, and I see it's heads again, well, the chance of me flipping 2 heads in a row is a half times a half, which is 0.25. So the same process is going on here. The chance of me choosing a person who is in group 2 is 40%, or 0.4. And the chance of me choosing a person who conforms is 35%, or 0.35. So the chances of both conforming, or both occurring, is 0.14. Finally, you can find the expected frequency of such people by multiplying the probability of such a person by the total number of people. In this case, it's 0.14 times 200, which will give you an expected frequency of 28. So I've just demonstrated by hand how it's calculated behind the scenes. There's also another way to calculate the expected frequencies, which will be in a separate video.